Alrighty, so today we're talking about physics, period and frequency relationship in physics. This can kind of be discussed in two sort of ways so far that I've learned, and that would be in a planetary motion, angular momentum discussion, and then also in harmonic motion as well. And there's something I'll talk about in there as well. But basically, what I want you to know is that period is represented by T, is period, and then F or frequency is measured in hertz. Now, period is the amount of time it takes to do one thing. So, one oscillation or revolution, we'll call it. So, a period is how much time it takes to get that done. So, if it takes 2 seconds for my period, or even for a pendulum, okay? So, it takes 1 second, 2 seconds, and that would be the period. The period would be 2 seconds per one revolution or oscillation. Hertz is the inverse of that. So, if I take t to the negative 1 power, that's going to equal my frequency, or frequency equals 1 over t. And so hertz just means time per second. So if I do something 2 times per second, that would be, I flip it over here. So 1 over 2, because 2 equals t, then it's half a hertz, or half a time a second. So because it takes 2 seconds to go from one side to the other, if this were a pendulum, um, for every second it does half of a revolution or oscillation. So this would be oscillation or revolution on top. Um, the oscillation or revolution really don't matter. It's the time piece that changes. Time is on the top for period and time is on the bottom for frequency. And if we're talking about hertz, it's in seconds on the bottom. So if you look at your computer clock speed and it's in gigahertz, 3.4 gigahertz, that tells you how fast or how many cycles it's doing per second. And so that's kind of what that means. And that's kind of the general relationship I wanted to discuss for today. Thank you for watching.